Welcome to another episode. Today I want to talk a little bit about this particular problem, this limit. Let's solve this problem. When you have a limit of 1 plus x to the power 1 over x as x approaches 0, let's take a look at what happened. This will end up with 1 to the power of 1 over 0, which is 1 to the infinity. This is actually an indeterminate form. So we had to figure out how to address that. For the indeterminate form, remember there is a L'Hopital rule that can address that. But L'Hopital rule requires that the limit has to be, or the function has to be in a quotient form. It is not in the quotient form, so we can't use a L'Hopital rule right away. But there is a particular technique to deal with this. One of it is using the log operation on this function, on this problem. Now, typically, if a problem is given to you like this, just limit this problem and say find a limit. It's not too obvious that you can use the natural log operation. But if you write this and set it equal to L, you can use the log operation on both sides of the equation, and that will be okay. So let's take log on both sides. Log L is equal to limit x approaches 0, ln 1 plus x to 1 over x. Now, in this case, then we can bring this 1 over x to the front. So we got ln L is equal to limit x approaches 0. 1 over x ln 1 plus x. But because remember earlier I said that in order to use L'Hopital's rule, you had to apply it onto a function that is in a quotient form, meaning something divided by something. Since this is 1 over x, then let's go ahead and turn that into like this, right? So if that's the case, then let me just use the same color instead of using green. We end up with ln 1, which is 0, and then 0. This is an indeterminate form. So we know that we can take the derivative on the top of the function, and the derivative on the bottom of the function. So we got ln L is equal to the limit x approaches 0. The derivative on the top is 1 over 1 plus x. The derivative on the bottom is 1. So that together can be written as just 1 over 1 plus x. And then if we take the limit as x approaches 0, then we end up with ln L is equal to 1. Now, since we're looking for L, which is the limit of the original function, then we can go ahead and take e on both sides. E to the power of ln L is just L. E to the 1 is E. So what does this mean? That means E, which is L, is this particular limit. X approaches 0, 1 plus x to the power of 1 over x. This is the definition of the natural number. This is the definition of the natural number. So if you graph this out as x approaches 0, it will approach to a very specific value, and that value, we define that as E. So in this case, I give you two things to think about. One is that a particular limit that gives you indeterminate form. We use the natural log on both sides as an operation, and this is a technique to get to a indeterminate form that will be in the form that we can use the L'Hopital's rule. So in this case, right, this is operating on using L'Hopital's rule on this, which becomes this. So, and then once we get to here, we are able to take end up with a easily understood limit. In this case, is 1, and then we reapply and then get the L back to get E. So that's the first idea. And the second idea is that this is the definition. For the exam, for the AP exam, we need to be familiar with this particular form. Okay? See you in the next episode.